Table 3 show the mass of ingredient that is needed for baking a cake, the cost and the selling price for two type of cake. So in a bakery shop in a week. So in order to minimize the cost, he need to use at least 8 kg of flour. So this one, so X chocolate cake, Y vanilla cake. So we have X chocolate, Y vanilla. So 0.4x plus 0.1y uh, at least greater than or equal to 8. And then at least 6 kg of sugar. So 0.1x plus 0.2y greater than or equal to 6. And then maximum butter 5. So not butter lah, it's margarine. Okay. So this one is a massive margarine here. Okay. So it's 5 maximum. So we have the 0.1 x plus 0.1 y less than or equal to 5. Okay. So number one, they ask us to uh, write three inequality. So part A, three inequality will be this three. Then B, 2 cm 10 chocolate, 2 cm 5 vanilla. On the so 2 cm 10 is x-axis, 2 cm y is the y-axis. And we will need to find the region that satisfy all three regions. Okay. So for this one, all multiplied by 4, then we have 10. 4x plus y greater than or equal to 80. X plus 2y greater than or equal to 60. X plus 5 less than equal to 50. Then we have the 0, 10, 20, 30, 40, 50, 60, 70, 80. And then we have the 0, 5, 10. Okay. And then no. We should write here 0, 5, 10, and so on. No need. Just write, just draw. So this one we have the 0, 10, 20, 30, 40, 50, 60, 70, and 80. Then we have the 5, 10, 15, and so on. Okay. So 5, then 15, 20, 25, 30, and then 35, 40, and so on. 45, 50, 55, then this one is 60. Why 60? So when x equal to 0, y equal to 80, no. So when x equal to 10, then 40 plus y equal to 80, y equal to 40. When y equal to 0, so 4x equal to 80, x equal to 20. So 20 is 0, and then 1040. So 20, 0, 1040. So 20, 0, and then 1040 is like this. Okay. Hmm. Then 5 will be 60. Yeah. So 1040 and then 020. So this is greater than, greater than. And then next, when x equal to 0, 2y equal to 30, y equal to 2y equal to 60, y equal to 30. So 0, 30. And then when y equal to 0, x equal to 60. So this one, 0, 30, 60. So 0, 30, and then 60, 0 here. And this one also greater than. So and greater than. So when x is equal to 0, y is 50, y equal to 0, x equal to 50. So for this one, we have the 50, 50. So 50, then this is 50. Okay, so less than, and then less than. So the shaded region will be here. So this is the region. So use the graph, construct in B, calculate the maximum profit obtained. So the profit for this one, so profit is actually the selling price minus the cost. 70 minus 35. So it's 35. 50 minus 30. This is 20. So the profit is 35x plus 21. So I will just use the 35x plus 20y equal to 35 times 20, then is 700. So when x equal to 0, y is, so 20y equal to 700, y equal to 35. When y equal to 0, and then 35x equal to 700, x equal to 20. So 35, 20. So 35 and then 20 is something like this. This is the profit function. And then this we move until the last point will be this. So the maximum profit will be 40, 10. So this one is 40, 10. Okay. So the this is C. So 40, 10. So the profit. So we have the 40, 10. The profit will be 35 times 40 plus 20 times 10. Okay, so 35 times 40 plus 200. So 1,600. So the maximum profit is 1,600. Maximum profit. Hence, the mass of flour that need to be used. So the flour is 0.4, 0.1. So mass of flour is 0.4 times 40 plus 0.1 times 10. So 16 plus 1 then is 17 kg. 16 plus 1, 17 kg. Okay, then. So this one is linear programming, Form 5, Chapter 7, linear programming.